Okay, so good afternoon, everyone. Okay, now it's 1 o'clock, so it's time for our class. Today is gonna be the last class for this semester. So we're gonna starting with the role of central bank. Okay, I write down CB. CB stand for central bank. Okay, when we talk about central bank, okay, we're gonna bring one of the equation that we talked before. Remember that we talk about five main equation, right? And for the equation number five, which is going to be the monetary policy laws, that is going to be the equation for the central bank. So I'm gonna write down here. This is. Oh wait a minute. This disappear. Um. Okay. So let's come back. So I'm gonna write down equation number five. The monetary policy rules is gonna be IT equal to pi t plus rho plus theta pi t minus pi t star plus theta yt minus yt bar. Okay, this is the monetary policy rules. Okay, the central bank gonna use this equation to determine whether they're gonna increasing the nominal interest rate or decreasing the nominal interest rate. So normally the central bank can control I. Okay, the central bank can control I as the nominal interest rate. So the central bank, they're gonna increasing I or decreasing I. It depends on two main factors. Okay, the first factor is gonna be about inflation. Okay, pi t minus pi t star. For the first bracket over here, when the country have the inflation problem, inflation is greater than inflation target, this bracket become positive. The right side of the equation become positive. So it means that the left side is going to be increasing. So the central bank going to be respond by increasing the nominal interest rate. Okay. On the other hand, if inflation is lower than inflation target, this bracket is going to be negative. The left side of the equation, the nominal interest rate is going to be lower. This is how the central bank going to respond. Okay, how they're going to change the nominal interest rate in response to the inflation problem. The second factor, okay, is going to be the bracket y minus y bar. Okay, what this means is when the economy is very good, yt greater than yt bar, this bracket is positive. When the economy is very good, what central bank gonna do is on the right side of the equation is positive, right? So it means that the left side is gonna be increasing. So the central bank gonna increasing the nominal interest rate. When central bank increasing the nominal interest rate, what does it mean? It means that the cost of borrowing is gonna become higher. So people gonna borrow less, they're gonna spend less, they're gonna invest less. So it can slow down the economy. Okay. On the opposite way, if the economy is bad, YT less than YT bar, this bracket is negative. The right side of the equation is negative, so it means that the left side is going to be lower. The central bank going to respond by lower the nominal interest rate down. Okay, this is how the central bank going to change the nominal interest rate respect to the inflation problem and the economy problem. Okay. Then let's see, okay, in the economy, we may have two main problems. The first one, okay, we may have a negative demand shock problem, okay, negative demand shock problem. This is the first main problem in the economy. Remember that demand shock is epsilon T. Negative demand shock means for some reason, for some factor, people gonna spend less. The total spending in the economy is gonna be lower. Let's drawing the graph. Okay, we have Y over here, we have pi over here. I have dynamic aggregate demand curve, DAD at time 0, DAS at time 0. The equilibrium point is stay at point A. GDP is equal to Y0. Inflation equal to pi 0. Okay. As you know, for the DAD equation, we have YT equal to YT bar minus A pi T minus pi T star plus B epsilon T. When you have demand shock, okay, negative demand shock problem, so it means that the epsilon T is going to be lower. Okay, what it means is it's going to make the if the right side of the equation become lower, it means the left side is going to be lower. Okay, so negative demand shock means for some factor, for some reason, total spending in the economy become lower. So it's going to make DAD curve shift to the left like this. DAS still the same. Equilibrium point change from point A to point B. As a consequence, the whole economy slow down. As you can see that the GDP Y is going to the left from Y1 to Y2. The whole economy slow down. In the same times, inflation become lower. Okay, inflation become lower. So you have two problems. You have inflation become lower. This is not a problem. Okay, the economy becomes slow down. This is a problem. Okay, and if we going back to this slide, when inflation is going down, central bank going to respond by lower the nominal interest rate down. Okay, when we have the slowdown of the economy, YT is less than YT bar. When YT reducing, so the central bank going to respond by lower the nominal interest rates. So you see that in this case, the central bank going to respond, okay, by the central bank going to respond by lower the nominal interest rate down. This is what they're gonna do. Okay, based on the economic slowdown problem and the inflation that's going down. Okay, so the central bank gonna respond by lower the nominal interest rate down. Okay, and then if we go to the second case, is gonna be about the positive supply shock problem. Okay, positive supply shock problem, VT going up. Okay, VT going up. So I'm gonna write down the graph over here. We have Y, O, and pi. I have the AD at time 0. I have the AS at time 0. Equilibrium point A. This is Y0 and pi 0. Okay, positive supply shock, VT, okay, increasing. This is happened in the DAS equation. Okay, DAS equation pi T equal to pi T minus 1 plus phi YT minus YT bar plus VT. Okay, this one is about VT. Okay, when you have a positive supply shock, it means that VT is gonna be going up. If VT going up, it means that the right side of the equation going up, the left side of the equation is gonna be going up. So in the same way. Okay. So in this case, when you have a positive supply shock, it means that for some reason the cost of production is increasing. Maybe come from COVID-19. We need to close a factory. You don't have a supplier. Maybe come from the war between Russia and Ukraine, come from the energy price that going up a lot. Okay, this is all make the cost of production increasing. When the cost of production increasing, everything become more expensive. Inflation is going to be higher, right? So we learned it before, right? If you have this problem, DAS gonna shift up. DAS curve gonna shift up. DAD still the same. The equilibrium point moving from point A to point B. And as a consequence, you have two problems happen in the same time. The economy slow down, Y1 to Y2. In the same time, you have inflation problem. Okay, inflation going up from pi 0 to pi 1. The economy slow down, and in the same time, everything in the economy become more expensive. However, the problem is here. Okay, when the economy slow down, based on this equation, when the economy slow down, the central bank need to lower the nominal interest rate. However, when inflation is higher, the central bank need to increasing the nominal interest rate. It's conflict. to each other, right? They cannot lower the nominal interest rate and increasing the nominal interest rate in the same time. They need to choose which way they're gonna go, going up or going down, right? Okay. So the way to solve inflation problem and the economic slowdown is totally different. Okay, totally different. So if we going back to the monetary policy rules equation, IT equal to pi t minus rho, plus rho, plus theta pi t minus pi t star, plus theta y t minus y t bar. If we going back to this equation, as you will see, we have, wait a minute, we have two brackets over here, pi t minus pi t star and yt minus yt bar. Okay, so two main problem: the economic slowdown problem and inflation problem. As you will see, in front of the bracket you have theta pi, in front of the bracket you have theta y. So now this parameter theta pi and theta y become more important. If the central bank care about inflation problem more than economy problem, okay, more than economic problem, okay, if they care about pi more than y, it means that theta pi is going to be greater than theta y. On the other hand, if central bank care about economic problem more than inflation problem, theta y is going to be greater than theta pi. So this is the role of theta y and theta pi. It's gonna showing how the central bank gonna care about inflation problem or the economic problem. Okay. Then since we know that theta y and theta pi is showing the attitude of the central bank about these two problems. Okay. So the next one, where is theta pi and theta y in the main model? So I need to remind you again about DAD. Remember that we have DAD curve like this, right? And DAD equation, YT equal to YT bar minus A pi T minus pi T star plus B epsilon T. This is the dynamic aggregate demand equation that we learned before. We saw this equation together before, and you know that A is going to be equal to alpha theta pi over 1 minus alpha theta y, and B equal to 1 over 1 minus alpha theta y. This is we learned it before, okay? And then what I'm gonna showing you here is I want to find the slope of the DAD curve, okay? What is the slope of this curve? Okay, slope, I told you many times, the way to find the slope is the slope always equal to delta vertical over delta horizontal. In this case, vertical is pi, horizontal is y. So the way to find the slope is delta pi over delta y. Simple like that. Okay. So we're gonna find the slope of the DAD together. From the main equation, yt equal to yt bar minus A pi t minus pi t star plus B epsilon t. From the main equation, what I'm gonna do is I'm gonna do the calculus, okay? Delta yt over delta pi t, or partial derivative, curve yt by curve pi. I'm gonna focus on yt respect to pi t. I do the basic calculus. What I'm gonna get is I'm gonna get minus A. Very simple. I'm gonna get minus A. And you should know that minus A is this guy, right? A is equal to this one. Okay. So what I found is I got minus A, right? So it's become minus alpha theta pi over 1 minus alpha theta y. Okay, this is what I have. This is delta yt over delta pi t equal to this guy, right? However, what I want is I want delta pi over delta y. So I can flip it up. Okay, I can flip it up. This is below you have delta y over delta pi. However, the slope is delta pi over delta y. So I can simply just flip it up. So I'm gonna get minus 1 minus alpha theta y over alpha theta pi. That's it. This is what I want. This is the slope of the DAD curve. Got it? This is the slope of the DAD curve. And as you can see, the DAD curve have a negative slope. It's going down to the right. Okay, and they have minus in front of it. Okay. So, okay, after we know the slope, you can see that you have theta y and theta pi in the slope, right? So it means that when central bank care about inflation problem more than economic problem, or they care about economic problem more than inflation problem, when theta pi and theta y is not equal, one thing is going to be greater than the other thing, is going to affect directly on the slope of the DAD curve. How? I'm going to show it here. Okay, slope of the DAD equal to minus 1 minus alpha theta y over alpha theta pi. As you can see, okay, you have theta y here and you have theta pi here. Okay, so if the central bank care about economic problem more than inflation problem, theta y is going to be greater than theta pi, right? Okay, so the graph of the DAD is going to be look like this. This is y, 0, and pi. As you can see, theta y greater than theta pi. Okay, if you're checking the formula in the slope, theta y greater than theta pi, it means that the upper part of the fraction is greater than the lower part of the fraction. So it's gonna make the slope become more negative. More negative is mean the slope of the DAD is gonna be steep. Okay, it's gonna be steep like this is the DAD at time 0. Okay. On the other hand, if the central bank care about inflation problem more than economic problem, theta pi is going to be greater than theta y. Okay, like this. And you can see that theta pi is on the lower part of the fraction. Theta y is on the upper part of the fraction. Lower part of the fraction is greater than upper part of the fraction. Is going to be make slope to be less negative. Less negative is mean that the slope of the DAD curve is going to be flat. So it's going to be look like this. This is the DAD at time 0. Okay, so the way central bank care about one problem more than the other problem is going to be reflects on the slope of the DAD curve. Okay, how about DAS? DAS still the same. Okay, this is DAS at time 0. It's the same. It's a 45-degree positive slope. It's like this. You have equilibrium point A. This is GDP Y0, inflation pi 0. Okay, equilibrium point A, GDP Y0, and inflation pi 0. And since the slope of the DAD is different, when you have the positive supply shock problem, okay, DAS shift up like this. DAS shift up like this. You can see that the result of this problem is different. Okay, the result of this problem is different. The case that the central bank care about economic problem more than inflation problem, on the left, you can see that the equilibrium point moving from A to B, GDP slow down just a little bit. However, inflation increasing a lot. This is because of, in this case, central bank care about economic problem more than inflation problem. So they're going to adjust the nominal interest rate to solve the economic problem first. Okay, and they don't care about inflation problem. They think that they're going to solve inflation problem later. So as a consequence, you can see that Y is going to the left, just a small gaps. Okay, because they're going to put all of the resource to solve this problem first. On the right side, the right side, the graph on the right, the central bank care about inflation problem more than economic problem. As you can see, the economic slowed down a lot, but the inflation going up just a little bit. See that? Because in this case, they care about inflation problem more than economic problem. They're going to adjust the nominal interest rate to solve the inflation problem first. Okay, so this is how it looks like. Okay, so the central bank going to care about one problem more than the other problem. Is going to reflect on the slope of the DAD curve. So far so good. Okay, next one. So we're done with the first topic of today. And next one, we're going to talk about the other topics. Okay, we're going to talk about the Taylor principle, or the other name we call it as a Taylor's, as a Taylor's laws. Okay, the Taylor principle or the Taylor laws is say that central bank need to be always keep theta pi to be always greater than 0. What does it mean? Okay, theta pi always have to be always greater than 0. They have a really nice meaning. Okay, if we going back to the monetary policy rules equation, IT equal to pi t plus rho plus theta pi t minus pi t star plus theta yt minus yt bar. Okay, and then if I assume that the economy, okay, the economy is normal in a normal situation, yt equal to yt bar, this bracket is going to be equal to 0 or disappear. And then our equation is going to be reduced form to it equal to pi t plus rho plus theta pi t minus pi t star. Okay, and Taylor say that theta pi need to be always greater than 0 or need to be always positive. What is the meaning of that? Okay, let me write down this equation again. It equal to pi t plus rho plus theta pi t minus pi t star. As you can see here, theta pi need to be always greater than 0 or positive. It means that when you have inflation problem, when inflation going up more than inflation target, what does it mean? It means that this bracket it means that, okay, theta pi always greater than 0, and this bracket inflation is greater than inflation target, this bracket also positive. So it means that when you have inflation problem, inflation going up, this term all are positive. Okay, so the right side of the equation is all positive, inflation going up plus the positive terms. So it means that on the left side, the nominal interest rate need to be increasing even higher than the inflation problem. Okay, again, theta pi that always positive, it means that the nominal interest rate need to be increasing even more than inflation. So if the nominal interest rate increasing more than inflation, what does it mean? If you come back to the Fisher equation, t equal to it minus pi t, when inflation going up, however, the nominal interest rate increasing even more. For example, inflation increasing 2%, however, the nominal interest rate increasing 5%. What does it mean? It means that the real interest rate is going to be positive increasing, let's say 3%. When the real estate increasing, okay, cost of borrowing become higher. Okay, when the real estate going up, cost of borrowing become higher, people gonna borrow less, people gonna spend less, people gonna invest less. Then in the end, inflation should be going down. right? When people spend less, borrow less, invest less, everything in the economy is going to become cheaper, right? Because when people stop spending the money, firms, they're going to sell the product. They need to lower the price down. So this one can solve inflation problem. Okay. So on the opposite way, if central bank don't follow the Taylor rules and make say the pi less than 0, it can creating a big problem. Okay. If the central bank not follow the Taylor's rule and let's set the pi to be less than 0, it can creating a big problem. How? Go back to the equation. IT equal to pi t plus rho plus theta pi t minus pi t star. Okay. If theta pi is less than 0 or negative, okay, when you have inflation problem, inflation going up, inflation is greater than inflation target, this bracket is positive. So you can see that positive and negative, when you multiply it together, it's become negative. So it means that when inflation become higher, it's going to have a negative term on the right. So it means that the nominal interest rate is going to be increasing lower. And what the problem they're going to have? Okay, the problem is here. RT equal to IT minus pi t. When inflation increasing a lot, the nominal interest rate going up just smaller, then it's gonna make the real interest rate going down. For example, inflation increasing 3%, nominal interest rate increasing only 1%. So it means that the real interest rate is lower 2%. This is gonna be creating a big problem, because when the real estate become lower, people gonna feel that the cost of borrowing, okay, the cost of borrowing become lower. People gonna borrow more, spend more, invest more. When everyone spend more and invest more, the product, service, good and service in the economy gonna become more expensive. Inflation is gonna going up, and it can creating what we call hyperinflation. Okay, everything is going to be super expensive in the economy. So central bank will not solve the inflation problem if they let the theta pi to be less than 0. Okay, not only that, if theta pi is less than 0, okay, they're gonna have the effects on DAD curve. Remember that dynamic aggregate demand curve, they have the slope equal to -1 minus alpha theta y over alpha theta pi, right? You can see that the slope of DAD always negative because they have a negative in front of it. If the central bank, okay, let's theta pi to be less than 0, so this term is going to be negative. And as you can see, negative and negative become positive. Okay, when theta pi is less than 0, it can make DAD curve to be positive, which is violated law of demands. You're going to have DAD curve look like this. Okay, that have a positive slope. Okay, this is gonna be a big problem. Okay, this is gonna be a big problem. This is violated the law of demands, because normally demand curve have to be equal to need to have a negative slope. And I'm gonna show you in the next slide how the problem is gonna look like. This is gonna be the graph in the case that we have hyperinflation. So let me showing you here. This is y, o, and pi. You have DAS at time 0. You have DAD at time 0. DAD has a positive slope and is steeper than DAS. And then you have long run aggregate supply. The equilibrium point is here, point A, y0 equal to y bar. Okay, pi 0 equal to pi star. Okay, GDP equal to the point that everyone get a job, full employment level. Inflation equal to inflation target. Okay, at point A, everything is normal. Okay, at point A, everything is normal. And then we have the equation yt equal to yt bar minus a pi t minus pi t star plus b epsilon t. And then you have the AS equation pi t equal to pi t minus 1 plus phi yt minus yt bar plus vt. So what I'm going to show you here is I'm going to show you that if we have a positive demand shock, okay, positive demand shock for only one period, is can creating a big problem, a hyperinflation. Okay, positive demand shock, where is it? It's here. If you have a positive demand shock for one period or maybe only one day, okay, positive demand shock is mean that for some reason people spend more the money. Okay, the right side of the equation increasing, the left side is going to be increasing. Total spending in the economy increasing. Okay, so it's happened in day one. Okay, if you have the positive demand shock in day one, DAD is gonna shift to the right. The equilibrium point moving from point A to point B, DAS still the same. As a consequence, GDP increasing a lot from Y0 to Y1. Inflation increasing from pi 0 to pi 1. Everything become more expensive. Economic become growing very fast. Okay, this is what happened in day one. DAS still the same. Okay, point A to point B. Next one, how about what happened in day two? Okay, what happened in day two? In day two, the positive demand shock already disappeared. Okay, so DAD going back to the original point. Okay, DAD going back to the original graph. So I put a comma 2, 3, and so on. Okay, how about DAS? If you look at the equilibrium point B, y is greater than y bar. The right side of the equation is positive. So it means that it's going to make inflation going up. Okay, so for DAS, it's going to shift up. Okay, shift up. Like this. This is DAS at time 2. DAS shift up, DAD shift back to the left. The equilibrium point going to move from B to C. GDP slow down a little bit from Y1 to Y2. Inflation increasing a little bit from pi 1 to pi 2. Okay. And then how about the next period? Time 3, time 4, time 5. Okay, the next period, time 3, time 4, time 5, DAD, no more positive demand shock. So it stay at the old curve, okay, that I put the blue highlight. Okay. How about the AS at point C? Y still greater than Y bar. The right side of the AS equation is positive. So it means that inflation still keep going up. So it means that for the AS, let me change to the green color now. The AS keep going up a little bit day by day. You see that? This is the AS3, the AS4, the AS5, the AS6. Okay, equation, the equilibrium point going up from C to E to F to G and to H. As you see, the equilibrium point keep going up to the right, C, E, F, G, H. So it's gonna make GDP to be increasing to the right to infinity. And in the same time, it's gonna make inflation going up to infinity. And it's creating hyperinflation. Everything is going to be super expensive. So, okay, this is because of what? Because of DAD curve become positive slope. violated the law of demand. And why DAD become positive slope? Because the central bank, they do not follow the Taylor's law. When they do not follow the Taylor's law, when inflation going up, the nominal interest rate increasing smaller, and it's make the real interest rate to be lower. That's why people keep spending the money. People keep borrowing the money, and they cannot solve inflation problem. Okay, it's all for this semester. We done here. And then I'm gonna give you homework, the last homework. This is homework 15. Okay, normally the homework is worded for 10 points, but this one I give you 30 points because this homework is pretty long. I want you to watch the documentary about Japan economy. Okay, this documentary called Prince of Yen. This is like 1 hour, 1.5 hours. Okay, you need to watch it more than one times in order to understand it. Okay. So after you watch this documentary, I want you to write down 3 pages, submit it here. Okay, I give you 3 weeks to do. Okay, so the due date is going to be the midnight of the Tuesday night, October 25. A lot of times to do. Okay, and today is done. Okay, this is the last class. We end of this semester. Don't forget that we have the final exam on Thursday, November 3rd. Okay, 3 hours from 8 o'clock in the morning to 11 o'clock. Okay, the exam is going to be at the econ department. I believe that for the international student, for the Chinese student, you are all in Thailand right now, right? If you are all in Thailand right now, the final exam is going to be on site, okay, at the econ building. Okay, and in the exam, no calculator. Okay, we don't have calculation in the exam. The exam is gonna based on graph. Okay, only about graph. So make sure that you understand all of the graph in my lecture. Every lecture, every day of the lecture have the exam. Okay, and the exam is gonna be writing. Okay, you need to drawing the graph and explain just like the midterm exam. It's gonna be around 10 questions, 10 or 11 or 12 questions, something like that. Okay, big questions. Okay, every question require you to drawing the graph and explain. So make sure that you understand all of my graph. Okay. Any questions so far? No? Okay, no more class. Okay, see you again on exam day. Bye-bye, everyone.